Hello, everyone. So today is lecture 16, and today we're going to continue on with the third step in the 5-step process. So that's going to conclude the new materials for this week, and then next week we'll learn the last 2 steps. So when you work on your team assignments this week, you're only going to complete the first 3 steps. So the population step, the method step, and then the new step we're learning today, which is the sample step. So I'm going to share my screen with you so you can follow along with some of the notes, and we'll look at a completed example together. So like I said, we're looking at the sample step today. If I can get this down here. Okay, so in the sample step, we are actually going to describe what we find out in our sample. So remember, our sample is just that part of the population, the people that we surveyed, or the individuals. I don't want to say people, because it's not always people, but the individuals that we surveyed and that we took a sample of. And here we're going to, again, have 4 pieces of information under this step. So it depends if we have numerical or categorical data. So you pick out this information in the population step, right? Under your unknown, you say it's either mu for numerical data or it's p for categorical data. So you already know from the population step what type of data you have, so you know what you're going to do for your sample step. So we'll start with numerical data first. So for my numerical data, for my sample step, the 4 pieces of information we need is n, which is my sample size, x bar, which is my sample mean, s, which is the sample standard deviation, and then I need to check for normality. You'll be given the sample size. You'll be told something like in today's example, like we sampled 80 students, okay? And that's your sample size. So it's very easy to pick that out of the problem. And sometimes I just highlight it, circle it, or underline it, write it off to the side. So then when you get to the step, it's already picked out of the information for you, or out of the problem, and you don't have to keep referring back to the original problem. Just makes it a little easier. Whatever you want to do, whatever works for you. X bar is my sample mean. So I have 2 ways of getting this. It's either going to be given to me because I will be given the summary statistics, meaning I'll be given like the sample mean, sample standard deviation, and some information like that, or I'll be given raw data. If I'm given raw data, then I just need to take that data, put it into a list in my calculator, and then I can find my sample mean and my sample standard deviation from there. So on the team assignment, you will see like towards the end, there's one that has raw data. So you'll have a chance to practice that. I know it's been a while since we've done that in our calculators. So I'm sure someone in your team will remember, but you're just going to go get your descriptive statistics. Okay. So that's where you're going to get the sample mean and sample standard deviation. Then my normality check. So we have to remember the normality check changes based on the type of data we have. So if we have numerical data, then I have 2 ways of checking normality. The first way is always the easy way out and the one I want to use if I can, and that is using n is greater than or equal to 30. Remember, this is our central limit theorem we talked about before. And all this says is that if my sample size is large enough, then I can go ahead and assume that I have normality. So if n is greater than 30, I love it because it's just easy way out, right? What you would do is you would just say that n's greater than 30, like check mark, it's done, yes, it's normal, kind of thing. So you just need to indicate to me. I don't want you just to say normal. I want you to show me how you know it's normal, right? Or if we don't have n is greater than or equal to 30, but we do have raw data, then we can go ahead and have our calculators draw out the NPP for us. That's my normal probability plot. So remember, we have to put the raw data into a list and then go to the stat plot, ask for the NPP, and then you hit that zoom number 9. That's how you get anything from the stat plot. If it's fairly linear, it doesn't have to be perfect, but just if it looks fairly linear, then you can go ahead and say, yes, it's normal. Okay. That's for my numerical data. The next one is for my categorical data. So again, I'm just describing my sample here, but it's just I have different things when I'm looking at categorical data. So I still have my n, which is my sample size, so same idea, it'll be given to me, I'll know. I have x. X is the number of individuals who have a specified characteristic. So X is the number of people that answered yes to the question, if that's what we're interested in. Or maybe we're interested in the people that answered no, then that's the people. But normally it's the people who've answered yes. Like that's normally what we're looking for. We normally word the question, so it's those yes responses are the people that we're interested in, like that's the study we're doing. So, so that's what we're looking at here. That is X, the number of people that have fit that category, right? They fit into that category. They have that characteristic. Then the next thing is P hat. P hat is just the top two being divided. It's X divided by N. We've gone over this. We haven't had to use it a lot in the past, but I gave it to you when we first introduced proportions. So here it is, X divided by N, and I'm just going to plug it in and write it as a decimal form. You'll see on the example today. And that is called my sample proportion, my P hat. Then my normality check here again, I'm going to look at, remember my normality check is different for proportions. So if you remember when we first started looking at proportions for my sampling distribution, we used N times P times 1 minus P is greater than or equal to 10, right? So we used P in that calculation. Then when we moved on to confidence intervals for proportions, we used N times P hat times 1 minus P hat is greater than or equal to 10. And now we're going to change the formula one more time, and it's called N times P naught times 1 minus P naught is greater than or equal to 10. So it's always the same formula, it's just what P value that we're plugging in there, that's what's changing. I want you to understand, in these calculations, we're checking normality on the curve. So the value we're plugging in for P is always the center of my curve. So when I'm looking at my sampling distributions, the center of my curve was P. So that's why I'm plugging P into this calculation. For my confidence intervals, the center of my curve was P hat. So that's why I'm plugging P hat into that calculation. Now, the center of my curve is the value from my null, from H naught, right? So that value is my P naught. So P naught comes directly from the null hypothesis. So whatever that value is, that is my P naught, that is the center of my curve, and that's what I'm checking normality with, okay? So let's take a look at, this is a really short step, by the way, so these 3 steps are good 3 to have on the week 1 of the hypothesis testing. So let's take a look at the example. I'm going to stick with the same example as we did last class because I want you to see how we move forward from one step to another on the same example. So we're still looking at the same example, which was the small percentage of students who approve the university's admin. A professor wants to convince the campus community that it's more than 67%. And I had to give you some more information because that was just the background of the problem. It didn't give me anything about a sample that was taken, right? A study that was done. So my new information, here's my second paragraph. It says the professor randomly selected 80 RIT students and asked if they approve of the university administration. 62 of them said yes. Now, if you remember, that's what I'm interested in, the students that approve. So it's the students that answered yes to the question, right? So last lecture in 15, we set up the population method steps, and today we're going to do the sample step. So I'm going to go on to the next page to get the completed example. I left the information here from last class, and I just kind of sectioned it off, and I said this is from last class, okay? So I'm going to highlight some information in here. So I want to highlight that it says 80 students. And I'm also going to highlight the 62 because the 80 students are the 80 students that are in my sample. So that means N is 80 and 62 are the people that have the characteristic, meaning they've answered yes to my question that they approve of the university's administration. So that's my X. So I'm going to go right down here to the bottom of this page where I have my sample. So N, like I said, was 80, my sample size. 62 is the number of people that said yes. P hat is 62 divided by 80, which is 0.775. And then the normality check. So this one's the only one that I think is going to be a little tricky for us, and we just have to get used to the idea. So it's n times p times 1 minus p, but I'm using p naught in my calculation here. P naught is the center of my curve. It comes from the null. I'm going to go up to my method step, not my population, my method step, and see what my null value is. It is 67%. It's 0.67. That's the value I'm using to check my normality. So it's 80, that's my n, times 0.67 times 1 minus 0.67, and that has to be greater than or equal to 10. It comes out to be 17.7. So yes, that's greater than or equal to 10. I can assume normality. So for here, I need you to show me the second line. I need you to show me this right here. Okay, the 80 times 0.67 times 1 minus 0.67, because at this point in the class, we have multiple ways of checking normality for proportions depending on the type of problem we have. I need to know that you're checking for normality with the right numbers. I need to know you're plugging in P naught in there. So I want to see that. You don't even have to write this last one out. You can go from here and say, okay, all of this, and then from here you can say, yes, it's normal, right at that point, and that's fine with me. You don't have to actually say it's 17. I don't care about that. You know it's greater than 10, then that's fine with me. That you're saying, okay, it's normal, I know that's true, all right? So there's that. So I need you to show me the calculation you're using, okay? I don't think I have anything on the last page unless it just came down. It did. Okay, so that was it for the example. So please let me know if you have any questions on this. Let me know if you have any questions on the teamwork. The teamwork's a little bit long, and that's okay. I just have a lot of problems on there because I want you to see the different types of problems that can come up, different topics. I mean, it could be anything, right? And it's 3 steps, and the steps are pretty short. It's just that population step right now for us. It takes a little bit longer because it's just pulling all that information out, and it's just going to take us a little while to get used to that. So that one might be the longest step of the process. So on the team assignment, I'll have you do all 3 steps. Just turn in what you have. I've made it into one document. So assignment 15 and 16 have been put together, where if we were still in person, I would have given them out separately. We would have worked on one today because this was such a short lecture. So I made them into one document for, you know, the report. So you're only submitting one document, and the assignment page is all put together as well. All right. Let me know if you guys have any questions. Feel free to email me. I did change the homework dates out because it was such a mess all last week. I have no idea what was going on. I couldn't even get in there to change the date. So I pushed it off to like the 9th or something. And let's see what else. So I will be on Wednesday at 12:30, and I will also be on Friday at 12. Okay. I hope you guys have a great day, and I hope you get outside to walk around in the sunshine if it's sunny where you are. It is here for me right now. All right. Thanks a lot.